Greetings and welcome. We are reviewing for our test. Yeah, Orange Zone. Talking about the Westfall. Polynomial radical equations. Bam, expressions, whatever. That's fine. I'm just excited here. Problem 27. This is all from the chapter review assignment and kind of the end of the chapter. This starts like around page 324. Here's problem 27. They just asked us to kind of like add or subtract in this section. So this was the first thing. Oh, minus sign. So I can't just start combining like terms. I actually have to distribute this minus sign to that entire right-hand polynomial. Let's see, where's my mouse at? Here it is. So I have 11x squared plus 13x minus 15 minus 7x squared, friends. Minus a negative 9 is plus 9x, and minus 19 is minus 19. Now go through and combine like terms. Does 11x squared have any friends? You bet it does. Uh-oh, it's friends with negative 7. Ooh. So 11 minus 7 is 4x squared.
I think I hate this problem.
You do?
Yeah, because of the way the answer turns out.
Okay, well, let's see what happens. 13x plus 9x, those are friends, so I add their coefficients while their variables and exponents remain unchanged. And then 22, huh? Yep. That would do it. Thank you, friend. You got my back. I appreciate it. It's like we're in a buddy cop movie, and you're my buddy. So here we go. Negative 15, negative 19. What's that going to be? Negative 34? And that's the answer, right? What, you don't like that answer?
I don't. You can't. It's just not right.
Okay. You just don't. You're not a fan of those numbers?
No.
Okay, I respect that. 33. Here is a problem. I could do this two ways. I could write this as 2b minus 3c multiplied by 2b minus 3c.
That's what I do. Then you have to do it again afterwards, right?
I don't know what you mean by again.
Yeah, you have like 3 parentheses at the end. Because you can't do 3 parentheses together. So you have to do like as it.
Oh, it's cubed. I didn't even notice the cubed.
Yeah. What are you doing?
What am I doing? Guys. You're correct. You're correct.
Good.
Man, I'm making mistakes. So yeah, that's a valid point. You can only distribute 2 together at a time. You can't distribute 3 together. It'll mess you up bad. Real bad. Let's see. Negative 3c times 2b is another minus 6bc. You also could have used a pattern for the first one. And then negative 3 times negative 3 is plus 9c squared. I'm going to combine some of these. So 4b squared minus 12bc, because I combine this guy and this guy, and plus 9c squared. However, that is still being multiplied by the 2b minus 3c. No, thank you. No candy corn for me, thank you. I'll distribute this way, actually, just because I feel like it. So let's see. 4b squared times 2b is 8b cubed. 4b squared times negative 3c would be negative 12b squared c. Okay, all right. Let's see, different color going here. Distribute the negative 12bc times that, and I would get negative 24b squared c, because b times b is b squared, right? And distribute times negative 3c is going to be plus 36bc squared. Okay, all right, we're moving right along. And 9c squared also has to be multiplied by both of those. So 9 times 2 is 18 bc squared. And 9 times negative 3 is negative 27 c cubed. Whew. Go through combine like terms. 8b cubed, got no friends. Negative 12b squared c and negative 24b squared c, those are buddies. That's a total of negative 24 of them. And when I combine like terms, they're that, yeah, man, you got my back. We're buddies. Thanks, man. Thanks, man. And then let's see, these guys are like terms because those are both BC squareds. So I just add their coefficients. 36 plus 18, what's that, 46? 56, I think, plus 56 BC squared.
No, it's 54.
This is the best video I've ever recorded. And then
I'm just going with that. You can do the math in my head.
Yeah, he's the math teacher, he knows.
minus 27 cubed. So I've combined like terms there, and I'm all good. Now, the other way you could have done this problem, technically there is a pattern for a minus b cubed. I don't think you guys remember it too much. It's a cubed would be minus 3 b squared c plus 3 bc squared, and then minus c cubed.
Where does the C come from? There's no C.
Oh, where is the C? You're right. Guys, I'm so embarrassed. What's up? Yeah, you ready for that?
Yeah.
Awesome.
I'm in the
You
cycle.
seriously wrote that down?
Okay.
Oh, okay.
Sorry, minus 3a squared b plus 3ab squared, and then minus b cubed. Wow, that's embarrassing. You guys are like, where did C come from? C came from there, okay? It was confusing me. Wow, I'm ready for this test tomorrow.
Another pattern that's like a to the third plus or minus b to the third.
There's a cubed minus b cubed, which is equal to a minus b times a squared plus ab plus b squared.
Are you sure it's just a squared minus b squared? Because I have it written here as a to the third plus or minus b to the third
Wait, which one's small?
equals a plus b, a squared plus or minus ab. It's like the sum difference of squared.
Are you?
Cubes.
Right. Yeah, that's this one here, right?
Yeah.
That's a
it
difference
could
of
be
cubes
plus
pattern?
or minus in parentheses. That, yeah.
Yeah, if this was a plus sign here, then this would have been a plus sign, and this would have been a minus sign. Yeah. I was just writing the minus version down because it was similar to this one here.
What?
Yeah.
Ugh.
But anyways, next question is 35. 35 was a division problem. They specifically wanted us to do synthetic division. So let me remind you how it's done. First of all, synthetic division only works when you're dividing by a linear binomial, whose leading coefficient is 1. So I would have -1 going in the box, and then 10, 5, 4, 0, -9.
Mr. Hicks can have this back at the end of the day.
Excellent.
Because he's going to be watching.
Perfect. So, so here we go. Where did that 0 come from, friends?
You got it's your placeholder.
It represents my x term, right? Which it was missing a term. So that's one of the first things you had to pay attention to. Not only does long division have placeholders, but so does synthetic division. And the method for doing synthetic division was add, multiply, repeat. So let's do that. So let's add this tens column. 10 and nothing is 10. Multiply, -1 times 10 is -10. Add, we've got -5. Multiply is +5. Add, I've got 9. Multiply is -9. Add, I've got -9. Multiply, I've got +9. And hey, what do you know? I got 0. That's nice.
Okay, can you say that for just a second?
Yeah, I'm not done with it yet. So this right-hand side is my remainder. So the fact that that's 0 tells me that this divided into it evenly, if you want to use that phrase. So then the -9 represents my constant term. This +9 represents my linear term. The -5 would be my quadratic term. And the 10 would be the cubic term. So,
The last one is always the rest, the remainder. The last one is
yeah, the last one's always the remainder. Yeah. So, a remainder. Why can't I get the right color? Here we go. remainder. And if we wanted, I could have done something like plus 0 over x plus 1. If the remainder was something else, that's how I would have written it. Right. So there's synthetic division. Let's see, keep on going. Hey!
Wait, I just need synthetic division.
Yep. Okay. Yep. So let's see, problem 45. This was just to try to simplify the radical thing. Let's do this a little bit at a time. Negative 8 parentheses squared is 64. The square root of negative 64 is
You're going to take out the I.
no real answer.
But can't I just take out
Is what you would have said back in the day, because there's no real answer.
well,
But there is a non-real one, so let's analyze this from 5.9's perspective. Yes.
On the test, are you going to make us have no real answer, or am I going to be able to go into like,
You could ask a question for clarity's sake if that was an issue. Yeah, we'd be able to ask a question. But from 5.9's perspective, this was from 5.6, I think, or 5.7. So let's do this from i's perspective. All right, so I know there's no real answer, but I could actually break this up into the square root of negative 1 times the square root of 64. The square root of 64 is 8. The square root of negative 1 is I. So I know, aha.
Yeah, that's what I got.
But it is not real.
Yes, it is.
But it does exist. It's just not real.
So no matter what, you end up writing it as no real answer.
Well, it depends on what section we were in. If we were in a section about complex numbers and imaginary numbers,
Then it would be a real number.
then we would have 8i as our answer. Yeah, but I have the test questions in chronological order, the order that we learned them in. And if there's any question on, if there's clarity that needs to be brought, feel free to ask. All right, let's see. I think I've got 2 more questions I'm going to do real quick. Or was it just 1? I think it's 2. There we are. Here's 59. This said simplify. So 27 to the negative 2/3 power. What does a negative exponent do? It would move it downstairs. So that would be 27 to the positive 2/3 power. And creepy hobbit moved upstairs. And what does a rational exponent mean? What does this 3 mean? It will become the index of a radical. I also heard people say cubed root, and I agree. So the cubed root of 27 squared. So I could put squared in here, but better yet, I realize I know the cubed root of 27, so I'll just square it after I take the cubed root. So what is the cubed root of 27? 3, and 3 squared is 9. 9. So 1/9, which, by the way, I don't know if you guys know that, is equal to 0.1 repeating forever. Yeah. Really?
Oh, yeah.
And last question we've got that I'm going to go over for this video's sake anyway. I to the 85th power. This required us to know this little chart that we had I squared is equal to negative 1, I cubed is equal to negative I to the 4th is equal to positive 1. And I like to put little tails on my i's and dots so I don't mix them up with the 1s there. Now, let's figure out, the best thing to use is this I to the 4th because 1 is our favorite. Question, comment?
I know the answer. Say the answer.
What do you got?
It's -1.
Negative 1 is what he's saying. So, let's see if he's right. I to the 85th, I'm going to see
No, just divide. I just divide 85
by 4.
The remainder is the sequence number.
Yep, so 80 divides by 4 20 times. And then I could fit one more 4 to get 84, right? So,
And there's one past that, which means.
yeah. So 4 times 21 is 84, plus 1 is 85. I like it, I like it.
I like it a lot.
I like it a lot. So I to the 4th is 1, and I to the 21st is 1. Or sorry, 1 to the 21st is 1, and 1 times I is I.
Yeah.
Okay, how come you couldn't just be like, okay, since there's a 5 at the end of it, you go
I made a
I to
mistake. I made a
How's it,
mistake.
So by your logic, I to the 5th should equal I to the 25th, or I to the 15th should equal I to the 25th? Is that what you're saying?
All I did was like, since there's a 5 at the end of it, I was like, oh, it could be whatever I to the 5th would be. So,
No. Well, let's test
I
this.
took such a huge shortcut.
So I to the 5th is the same as I to the 4th times 1. I to the 15th is the same as I to the 4th to the 3rd times, let's see, that'd be 12 times I cubed.
Yeah.
So that, these would end up being different. And I to the 25th is I to the 4th to the 8th times I. So this one would be I, this one would be I cubed or negative I, and this one would be I. And those are not equal with respect to each other. So you can't just look at the last term, you actually have to figure out how many times does that exponent evenly divide by 4. Comment, Aaron?
So I didn't get the right answer to that because I made a counting error, but my strategy works, right?
Correct, yes. Yep, that's exactly what I do. So I divide 85 by 4, figure out the remainder, and then the remainder is exponent. Because I to the 4th is 1, and I'd rather break it up into that than I to the cubed, which is like that. If I broke it up into I squareds, that wouldn't be bad either. I mean, I could have broken it up into I squared to what power? The 42nd power times I, let's see, that would be 84. Did I do that right?
Yes.
I squared is negative 1 to the 42nd power. And a negative 1 to an even power is positive 1, and I'd end up with the same answer. But I just choose I to the 4th because 1 is an awesome number to work with. It's like super friendly as far as multiplying stuff by, whereas some of the other ones are less friendly. So that's why we always preferred to work with I to the 4th. So, thanks for watching, Internet friends. Best of luck on your test tomorrow. Boss fight.